Hello, everyone. Welcome to the binary episode of the podcast for this week. Before we get into the topics, we'll cover the spot the Vuln solution for yesterday's episode, which I must say had some really quick solutions. I think there were some replies to the tweet that were correct before the show even went live. So, very quick solutions on that. But Z, I'll let you cover what it is for those who are curious on it.
Yeah, pretty quick. And apparently there was a Hacker News post that talked about it talked about the fundamental issue here. That being basically the difference in the maximum negative number, or I guess the minimum negative number, negative 128 versus, or now I'd probably have to look it up because I'm not confident in my own numbers, but on one end, negative 128, I'm pretty sure, and then on the other end, it's positive 127 for a single byte, but that extends out. There's that one number difference. And so the problem is line 5 on this, so it's reading data from a socket, has its max packet, or has its buffer created, and then just reads from the socket some integer. The issue is when it goes to check the length, it checks, if the length's 0, make it positive. How do they do that? By multiplying it by -1. Now, this mathematically works. Anybody kind of reading that on a logical, you see the intent there, take a negative number, make it positive. The problem has to do with what I was just saying about kind of the asymmetry in how many numbers are positive versus how many numbers can be stored as a negative. So what happens is when you take that maximum negative number and multiply it by -1, due to how the binary works out and the truncation of any bits that end up spilling over beyond the sign bit, multiplying it by -1 gets you the same value when you're multiplying that one value, the maximum negative integer. So that would be, and if you're not familiar with 2's complement, I don't know how much detail I really want to go into talking about how that ends up working, but essentially the maximum negative integer is 1, the signed bit, and then everything else will be 0. And the minimum -1 is always just every bit. So when to flip a number, you would negate it and then add 1. And of course, another thing, now that I'm talking about it, I'm not entirely confident if it's negate and add 1 or, yeah, it is negate and add 1. Anyway, it basically comes down to problems in the math, in how the computer is doing the math. I won't dive into many more details, but
I'll leave it at that. Computer math is hard.
Gotta remember, don't want to misspeak on it, really.
Yeah. Something I liked about this challenge is it's actually a pretty realistic scenario because, I kind of learned this recently. When you're dealing with sockets and doing networking and stuff, it may seem weird if you're looking at this example, like why would it be reading the length before and then using that for a read? When you're reading like large amounts of data, this isn't really an issue I've encountered when using sockets for like generally small packets, but when you're getting into like kilobytes and megabytes of data, you kind of have to send that length first to have a reliable read because, I just said computer math is hard, but networking is even more hard because you have to deal with like packet loss and just buffering and all that stuff. So this is a pretty realistic scenario.
It is, but I will say, like, in general, if you're writing code, reject invalid data. Don't try and fix it, because that tends to be where you see bugs getting introduced. You see a negative length, reject it. It's basically that simple. If it were to just get rejected, there wouldn't be an issue. It just happens to be they tried to fix the length by doing multiply by -1.
Just like the MySQL bug yesterday. Same kind of idea. Where we talked about
yeah. But it just comes down to it's trying to fix the input rather than rejecting bad input. And in general, that's adding complexity that will eventually end up biting you.
The other thing is for a length, you shouldn't be using a signed integer here, ideally. You just use an unsigned length because there should never be a scenario where you have a negative length, really.
On the other hand, having a negative length is like just kind of a trigger that, hey, something is very wrong. And you actually kind of have a check on that. Like if you shouldn't be reaching that length at all, ever. And they do the max packet thing. I mean, in theory, if it's unsigned, the max packet would be sufficient. But there is an argument to be made when it comes to using signed values as a bit of the warning system to see things become negative when they get too big. If you've got a number that should get large enough to overflow in an integer and make it negative, you probably shouldn't even be using integers in the first place. You should be using a larger number at that point. So there are some arguments to be made around using signed values as a sort of warning system. I don't know if that really makes sense here, but there is an argument that exists on that.
Yeah, but like you said, if you are using the negative length as an error indicator, then you should be bailing out. So, yeah, just kind of something to look out for. But yeah, so we'll move into some of our topics for today. First up, we have a post about an overview of 0 days seen in the wild in the last 7 years. This is based off of Project Zero's tracker. They have like a spreadsheet where they track 0 days they found in the wild. Originally, I thought that was just ones that P0 found in the wild, but Z corrected me yesterday. They do keep it updated for other things that are found too. Nothing super surprising in the post. It might be a bit of a shock. So I mean, I guess we'll get into what some of the statistics are before giving opinions on them. But yeah, so they found that first they talk about products. So Microsoft had half of all of the in the wild 0 days that were found. They affected Microsoft products, which may seem like a bit of a shock when you look into it, but then when you realize how diverse Microsoft is and how many products they have and their market share, then it kind of starts to make sense, right? Like you have Microsoft SharePoint, we see a lot of stuff in Windows, Office. They have a lot of different product types that get attacked.
And a lot of things that are being used by like your general user. One thing, it is kind of a notable absence that there isn't any just call out of like Linux here. You'll see Google, which I believe includes Android, but you don't see anything like Linux being called out directly. And I highly doubt it's the case that there were no vulnerabilities against Linux seen in the wild. But more either on the fact that whoever reported or were reporting on these things just weren't reporting on seeing something Linux thing. That's maybe one part of it. Another part of it is generally when we talk about things being in the wild, a lot of times, at least when we cover them, it tends to be things that are also client side, not exclusively, because we will talk about like, I mean, the SharePoint, as Spectre just mentioned, is a case where technically that's on a server being exploited. And it is kind of notable here because like Linux has a pretty significant market share when it comes to server side. Plenty of servers are out there running Linux. How often is privilege escalation done with a Linux LP versus, just abusing some privileged application? Not sure. I don't have the stats on that, but it is kind of notable there. And yeah, I mean, seeing Microsoft at 50%, it surprised me a bit until I scrolled down and saw that was including Windows and Internet Explorer and Office, and obviously any Windows kernel bugs, Defender, and everything else. Like, there's a ton of stuff fitting under Microsoft, whereas the other companies like Chrome and Android for Google, that's a lot smaller of an attack surface.
Now that I look at it a bit more, one thing that does surprise me a little bit is how Adobe has a higher share of 0 days than Google. Just because like Adobe, so they mainly account for Flash and Reader, Flash being like 85% of the Adobe bugs. Flash has been kind of dead for a while
But there
now, I
were a
thought.
lot of Flash bugs for a
Oh yeah,
time.
Flash was a
Flash
0 day farm.
was, yeah, like that's kind of the key. Like it's Flash at 85%, and this is in the last 7 years. So that would have been on the tail end of Flash, but
That's true.
still long enough for Flash to have made a very significant impact on that. Whereas like Chrome has never been the bug farm. It's always been, the PDF reader or just Adobe PDF rather than actually being Chrome as the main target. So I think it kind of makes sense. Adobe was just super popular. And of course, Reader comes in there too, as being a somewhat common target.
Good for hitting like enterprises where there's a lot of PDF sharing and stuff going around. So that one makes sense. But yeah, I mean the targets here, like most for the most part, it's not really that surprising. You see a lot of like browser stuff, Chrome, Firefox, WebKit. That's expected. Android, iOS, and yeah, like you said, the only notable absence is like Linux, where like Windows and Windows kernel is included in that list. And I think a lot of that comes down to not so much that Linux isn't being exploited in the wild or there aren't Linux 0 days floating out there. I think it's more just the case that they're harder to capture and find from like a third party context because Windows, like there's a lot of like I think a lot of the ways they get these reports is through doing like crash collection and whatnot. So like Windows
Yeah,
has a
perhaps
lot of telemetry
also,
in it. A lot of antiviruses have telemetry in it. So you'll see like exploit samples making it to antivirus companies and stuff, right? Whereas on Linux, I don't think that channel for getting crash reports back to the vendor is really there to the same degree. So I think that's why there's a bit of a bias where you're not really seeing Linux show up in these charts except for Android.
yeah, I mean,
Because Android does have that crash
there
reporting
is
stuff in it.
endpoint protection that deals with Linux, but that's going to be deployed on a lot fewer machines compared with like the number of machines running Windows or just running an antivirus on Windows.
Yeah.
It's definitely going to be a smaller group. I guess the other kind of surprising thing out of this was they looked at the average patch time between discovery and patching. Of course, the standout one to call out is Qualcomm at 167 days between discovery and patching.
Yeah, that doesn't
But
really surprise me.
I mean,
I mean,
it's hardware to take. It has a longer cycle. Microsoft at 41, Google at 5 was a little bit surprising. I mean, I guess not surprising, more like, good on them. I think 5 is completely fair. The best one on here was Cisco at 2. Um, Most of them all like Apple at 9, Adobe at 8.2. Well, 2 and several more digits. I don't know why they went so specific on Adobe and nobody else. I guess they do have a few others, but I don't know why they did that. Like measuring it down to that accuracy just
down to the like
feels
microsecond of the day.
it feels that way. But yeah, I guess I did misspeak by saying nobody else. You can see at least 4 others on there, or 3 others on there. But yeah, most of them are all in that 10-day range. It's Microsoft at 41, and that probably has more to do with the fact they push more on like Patch Tuesday being a monthly thing. Oh,
Yeah, so this has always been something that I haven't really been a huge fan of by Microsoft, and I guess this is a good launch point to talk about it when we're looking at these
well,
patch
we
timelines.
had a discussion about like Patch Tuesday and making that choice a couple weeks ago,
We,
I think.
I think it was longer than that, but yeah, we have certainly had that discussion before. But yeah, I mean, I'm generally not a big fan of like pushing off fixes to consolidate them in these like patch Tuesdays. Um, I mean, I kind of get why they do it. It has trade offs, obviously they feel it's worth it. But yeah, I mean, overall though, this chart isn't really that surprising to me. Microsoft being at 41 days, I don't think that's egregious, but it is high compared to other companies that are on the chart. Qualcomm, like you said, I think that is a bit of a special case because Qualcomm is more on the hardware side of things. And the other thing is too, I mean, Qualcomm's just never really been that great on a security standpoint. They've had some really meme issues. Um, there's also been some complications when it has come to dealing with reports and fixing issues. So, I mean, them being the worst here, it's you know pretty pretty straightforward. Like, I
Yeah,
don't
I
think that
mean,
was a surprise.
I do think a lot's explained by the hardware aspect. Just it's got a longer cycle. It's still quite long. Um, and maybe it is some stuff they could have patched quicker. Oh no, on the Microsoft point, you're comparing with everybody else on this list, and the thing is, like we were just talking about how Microsoft has a huge attack surface. They also have a huge development team, but like I could imagine there's more of an overhead also on kind of getting things out and collaborating to fix things. When it comes to the whole Patch Tuesday, like I said, I think we've had that discussion in the past already. I I kind of just see it as there are trade-offs with it, but it's a decision Microsoft has made, and I think it's a decision that you can at least argue on behalf of. I'm not the biggest fan either. I'm not that against it though. Um, but yeah, I
But
do
it does
feel
explain
like
their showing in this chart, so that's why I
yes,
wanted to bring it
yeah,
up.
I believe that's going to be a big part of it. Is just the fact that they intentionally delay patching. Beyond that, though, they also just have a lot more products than pretty much anybody else on this list.
Yeah, just by the nature of the number of products they have, that makes it more difficult. So yeah, that's a
As-
fair thing to point out.
And I guess you mentioned like compared with everybody else on this list, and this is a choice list, place where they've had these Odays in the wild. Um, you can kind of think though, like there are going to be plenty of companies that aren't prominent enough to make this list and have nowhere near that patch response time.
Yeah, yeah. So one thing I would like to see, and unfortunately you don't really get that with this post, it'd be interesting instead of just looking at it as a whole, like summing up the last 7 years and then doing, charts based on the 0 days that were found. It'd be nice to see a timeline over the last 7 years to see, like, okay, how many 0 days were found in this product in 2016 compared to 2017 or 2019. You know what I mean? So seeing like a line graph of where product 0 days are being discovered and trying to see if there's any trends, that would be very interesting to look at, I think. And the data is there, like the spreadsheet is there. You can go and do that. Um, it's just they didn't do that here, but like I think that would provide some useful insights too. So, maybe somebody can do that, or you know, cuz I think there would be things to talk about there too, but that's not in this post, but that was just something I was thinking about while we were going through the stats. Anyway, not too much more in that post. Um like I said, not too much surprising, just gives you a solid look at where the security landscape has been in the last 7 years. All right, so we'll get into some of our exploits. Up first, we have a blog post from Sonar Source on Squirrel, which they state is an open source interpreted language for game development. Apparently, it's used in CS:GO, which I learned when I read the post. I'm not really familiar with Squirrel, but I also don't do too much in the game dev area. Like I don't do
Well,
mods or anything.
so it's a little bit more than just game dev. Obviously, useful with game dev. It's kind of a similar market. Are you familiar with Lua?
hmm
Yeah, so it's
yeah, I've
pretty
seen
much the same
Lua
sort of
used in game
market.
dev quite a bit.
Except you get objects. You don't have to like hack at it with tables. Squirrel Lane kind of gives you a bit more object oriented programming features, proper objects, but it's kind of competing in that same realm of being an embeddable language. So that makes it nice for some games. But I
Yeah,
guess,
so what it's primarily used for in games, just kind of extending on that for people who might not be familiar with Lua's usage in games either, it's really useful for like higher level scripting with doing like plugins or mods or just generally like UI stuff, like stuff in that area. So in CS:GO, for example, that's where it's used. It's used for custom game modes and maps, which you can download off the workshop and host servers that run it. So, like, obviously, because that language can be written by mod developers and it can be installed on servers, it has to be sandbox, or else malicious maps can attack the host machine if they get too much access. And that's basically what the end game is here: is escaping the VM that's used for Squirrel Lang in order to pull off that attack. But yeah, sorry, go ahead, Z.
Yeah, well, I was just going to dive into the details of the actual vulnerability here, which is a out of bounds access. Due to confusing or being confused about whether or not it should be accessing the fields or the methods of a class. Sounds a little bit weird, but what's going on is kind of straightforward, actually. Internally, when you kind of declare the class, it's going to be backing that up with some internal data structures, like with how it actually compiles it down effectively. So when you have a field, it's going to, when you declare a field, it's going to have a separate kind of internal array called underscore default values. And every field is going to have its value or default value in that location. Well, pointed to by the default values array. Similarly, you create a method, it's getting pointed to inside of the underscore methods array. And then there is a separate array called members or underscore members, and that are not an array, sorry, it's a separate hash map. And that one is how they get the index into those arrays. So you'll have your members. I think they have this visualized somewhere. Or I thought they did. Anyway, you'll have your members hash map, and all of the fields and all of the methods belonging to that class will be in that hash map, can be looked up in there, and the value that gets out will be the index in its respective array. And then it just uses the first byte, and specifically 2 bits out of the first or most significant byte of that value to indicate whether or not it is a field and should be looked up. This index should be looked up in the default values array, or if it's a method and should be looked up in the methods array. So the confusion happens by being able to trick it that when you end up calling for an access on a method, it thinks it's actually accessing a field. And that ends up happening because it's storing this metadata in that same index value, but it's not preventing you from creating more methods than would fit inside of there. So what they do is the member, a field has this 0x02 as its start. It's specifically looking for that 2-bit of the most significant byte, whereas a method will use the 1-bit and just will have that set. So if you can create 0x2, 0, just a lot of methods, the index that it's going to expect is just naturally going to have that field bit set. So later when it actually calls, like, is this a field? Yes, it is, even though it's not. So that ends up creating the effectively a confusion there, where it will access, way outside the boundaries of where that default value is actually set up. At least if you create a class that only has 1 field, but like however many methods in it, it'll end up accessing whatever index that method was at, out of bounds, effectively. And it will, so the access, it will mask out those 2 bits that it uses for metadata. It'll mask those out, so the actual access out of bounds isn't all that far out. Like if you're accessing like what would be like the I guess 2 millionth hex or 2 millionth and 5th hex, then it will only access out of bounds like 5 indexes, which is fairly reasonable. So what they were able to do to actually attack this is through a little bit of heat feng shui, is putting some user controlled data next to the default value, so the out of bound access goes to more attacker controlled data. Had a attacker controlled object there, and effectively what they did was they ended up tricking the access to returning a array that started at null 0x0 and had 0x FFFF all the way up through 64 bits of data, basically giving them access to read write the entire address space as this field. And then from that point, of course, it's fairly easy to find some function pointer to overwrite and get your generic code execution. Overall, like, I thought it was a cool bug, but it's one of those cases where, like, storing that metadata inline is always dangerous. It kind of makes sense. They're trying to save memory, but it is a dangerous thing to do.
I mean, again, I'm circling back to something I've said before with these types of issues, but by trying to embed it directly in the value instead of just using a separate object, you are penny pinching on memory. You know, it's not like the 1990s where we have
this
really
is an
heavily
embedded
restricted
language.
RAM. Yeah, but
that
still
makes a difference here. Like, I understand trying to penny pinch more when those pennies add up and actually do make a difference when, like, they advertise on how much memory they take. Like, I get it. I also agree with you. Like, in general, we generally have more than enough memory. It does add up, though, and I get where they're coming from in this case. It's just, like, you need to take care when you do that you're not giving generic access to basically the whole thing. And allowing that other value to overflow into it.
So we can kind of revisit a topic or a theme that we explored last week when we were covering a WebKit bug, because you can classify this vulnerability in two different ways. They classify it as an out-of-bounds access. Really, what this boils down to is a type confusion, because they're using, you know, that most significant bit, or the most significant byte as a type, and the user is able to control that type because they have full access to the value. So, yeah, I'm kind of thinking like maybe this would be more apt to describe it as a type confusion, just because, like, when you see out of bounds access, you're thinking like, you know, bad size calculation or something like that. Whereas this is more of a just the user shouldn't be able to control the type. So yeah, another one of those bugs where you can kind of go like I can see both sides. But yeah, to me this is more of a type confusion.
I'm not sure if I'd really call it type confusion, just because like, I do get where you're coming from, like, but it's technically accessing I believe SQ object in both cases. Like, I don't believe it's actually changing the object type at all.
But they're both what it's expecting. Changing the container that's accessed.
Yes, exactly. It's changing the container that's accessed so that you end up accessing out of bounds. But it's not confusing the type as would be necessary for type confusion. I think that's the distinction that would make me not want to call it a type confusion. Like, I get where you're coming from. There is a confusion happening, but it's more of, like, you know, variable access confusion, I guess.
Yeah, it's a little bit tricky. It's a weird and cool bug because
it's a great bug.
Yeah, it's not something you're gonna run into in a lot of cases. Like, it's kind of unique to how the application is structured. I mean, I say that there has been similar issues like this in other products. Like, don't get me wrong, the PS4 kernel actually had a very similar bug to this. It was the basis for the 4.05 issue. But yeah, it's just not something you come across super often compared to other bug classes. So yeah, that's why I really like this blog post.
Yeah, and it was a well done.
They did a good job. Exactly. I think they did a really good job explaining the issue. I really love when they do these diagrams and stuff just to highlight the way it's architected to somebody who's not familiar. Just, yeah, overall a really good post. All right, so next up we have a topic that turns the tables on attacking Linux through the kernel instead of using the kernel or attacking the kernel. This one is a kernel bug that leads to the exploitation of suid binaries through the crash dump mechanism. So they kind of go into some background here for those who might not be aware of how core dumps are handled. first, like they focus in on this dumpable attribute. So every process in Linux gets a dumpable attribute, which can be one of three values. It can be 0, where it's not dumpable at all. It can be 1, where it's dumpable, or it can get this special 2 identifier, which is called set uid safe, where it's dumpable, but only if the core pattern, which the user can control, is an absolute path or a pipe. Well, the problem is the ESIS call that eventually calls this begin new exec function will set a dumpable value on a new process if the privileges are changed so that the real UID is equivalent to the effective UID, and the current group ID is set to the effective group ID.
Well,
So
so
basically, if you're running a child process, it's running as like root, for example.
it's well, I don't think the problem here is really with exec or not exactly. Obviously, they're able to abuse this, but it makes sense. Like it's deciding what the dumpable thing is based on, is this a suid binary where it's running with more privileges than the user actually has, in which case it's not dumpable, um versus it being dumpable when you're running it. Your same the effective user is the one who's running the program, or the actual user is the one that's running the program. Like it makes sense that it's doing this. I don't know, I'm not sure if you really intended to, but it sounded like you were kind of just putting blame as like it shouldn't be overriding dumpable, and it makes sense that it's not letting you dump things. I'm not.
So
Oh, go ahead.
I believe the problem there is that they should have been using the set you would save core dump value instead of just setting it as like 1 as dumpable. Now they're not totally clear on that and explaining what they think the um patch should be, because if the core pattern was an absolute safe directory, then this attack wouldn't work, right? So, and that would be enforced by the set you would safe value. So that's what I believe the bug is here, just the way I'm reading it, is that they're setting it to the dumpable value, not to the set you would safe dumpable value.
Okay, so
I
I'm
could
not
be wrong
exactly
there,
sure
but
where the set you would save dumpable value should actually be used. I'd assume that that was actually more of a special value. But the key thing here, and this is what it relies on, is the fact that the program running, um, like a suid, if you just have a suid binary and it executes another binary, that isn't sufficient to turn it into a dumpable. Um, what's needed is that suid binary needs to change, like it needs to call secuid 0, assuming root. It needs to change all of its IDs to 0. They all need to be consistent in order for it to match that first flag. Um, like it does rely on that condition also. It's not as easy as just any suid binary is vulnerable if it starts another binary.
yeah, it needs that path to be taken where the UID and GID need to be equal. To the sorry, the real one needs to be equal to the effective one. Just wanted to clarify there. Uh, it gets complicated when you're talking about like UID and GID in Linux, because there's like 3 different types. You have like real, effective, and I think there's another one that I can't remember the name of. But yeah, like you're saying, they have to be equivalent for that path to be taken for the process to be dumpable. Um, the other thing that is important there too is the fact that the process owner's permissions will be used to create core dumps that are generated. So that's where the privesc angle kind of comes into play there.
Yeah, and
So
I guess we
effectively,
should touch on what the actual issue is here too, which
yeah, exactly. Um, Effectively, you have this situation where you can have a root process that can create a core dump anywhere, since the user can control that core pattern as root. So it's technically in like a arbitrary root file, right? Though the contents aren't totally controlled because it is a core dump. It's not like you can just write whatever you want. You can try to get control over contents that are in the core dump, which is what this attack relies on. One way you can do that is by setting an environment variable, for example. So how they abuse this is they note that the log rotate d daemon directory can be written to with a core dump, and the parsing for configuration files there is very loose. Um, so like even if there's a bunch of garbage data, it'll just skip past that until it recognizes a valid configuration. So if you can control any contents going into the core dump, which you can for like an environment variable, you can smuggle in a log rotate configuration and get that read. have it execute a reverse shell or something to that effect to get a privilege escalation.
Yeah, and that's
Um,
just clarify, that's because in log rotate the configuration can include first run command, which effectively is code execution or script execution from there. So really straightforward. You set first action to whatever you want.
yeah,
And you'll get code execution. I guess one detail that's kind of been skipped over here is the fact that you do need to be able to crash the second program that ran
you
in
need
order
to
to get a
trigger the core
core
dump to
dump.
happen.
Yeah,
Yeah.
you need core dumps happen when a program crashes, and then does these permission checks, dumpable, and all that. And they had a fairly reliable way of doing that, and that's just using R limits. Setting the R limit CPU to 0 effectively meant that as soon as they started up another program, it would be killed, and it would send the appropriate signal to get it dumped.
So that was one trick. That works since commit from August of 2019. On older systems or systems running an older kernel, that won't work because they do have checks against 0 for setting resource limits. So in that case, the other trick that they had for using attacking older systems is by sending a sigquit system, or a sigquit signal, which can be done through the TTY driver. And this is a little bit weird, I thought, because I wasn't really aware of this caveat, but generally, like inside of a shell or whatever, you can't send a sigquit signal to a higher privileged process, right? You can't just tell it to crash itself. But through the TTY driver, um, it allows that signal to go through, even if you're sending to a higher privileged process. So it's just kind of this, I guess, subversion where it just kind of walks around, um, like other places where that privilege level is enforced. Through TTY, it just isn't. So that's another trick they use is they can just send a sigquit character through the TTY or terminal subsystem, and they can cause that crash and trigger the attack.
Yeah, I mean, it feels somewhat justified because usually the person sitting behind the terminal who started a program makes sense that they could also like kill it. Um, so I kind of get where they're coming from on that one. That's it. On the whole, like it's really just a logic issue over how do you deal with those suid binaries that end up starting another program themselves, especially those that take over the UID and GUID. We keep referring only to UID there, but I believe it actually I might be mistaken there. Did it have to take GUID also?
It did, yeah.
Or
I believe they, if you look at the code
yeah,
snippet, they
calls
pasted
set
it.
and set U and
Yeah.
set G.
But yeah, I mean, the big thing there is just like, I can't really recall any other instances where I've seen a kernel bug that's being used to attack user land to get a privilege escalation. That's kind of a weird route to take, and turns it on its head. So that was kind of the fun aspect to that
Yeah, I mean, I
vulnerability.
like this post for that. And I mean, it's a fun little more of a logic issue than crazy memory corruption stuff.
Yeah. That said, we do have a memory corruption for Linux as our next topic. This is a Project Zero post from Jan Horn on a Linux kernel bug discovered in the TTY subsystem. So I guess we're also continuing on the terminal subsystem too. This bug is a race condition due to bad locking in the TIOC SPGRP ioctl for setting the process group. Um, Basically, when modifying the reference counts of the old and new process groups, they try to do locking by taking a lock on the TTY object. It's a spin lock, I believe, but that's not sufficient because pseudo terminal pairs are a little bit special in the way that both ends of a pseudo terminal pair can access the same state, even if they have different TTY structs. So, because the different ends don't use the same lock, but they're accessing the same memory, the locking pattern there is effectively useless in that case, because it's only preventing concurrent access on one end of the pair, not both. So that can cause the reference counts to become corrupted, where the old PID object could have its reference count decremented one too many times, and the new PID on either end incremented one too many times. With that decrement, there's the use after free condition there, because when the ref count hits 0 prematurely, it'll get freed while the PID is still being referenced. The use after free is a bit tricky to exploit though in this case, because the PID object is allocated in a special cache that's used for only like 3 different objects. It's used for PID, sec file, and epitem objects, which I'm not familiar really with those latter two. Um, and the situation here is a UAF write, as I understand, because you can use the ref count field to cause memory corruption on any overlapped object. Um, but because it's not in a generic cache, you're kind of limited in the objects that you can, like a reallocation primitive. It's kind of hard to get a target object that's useful overlapped. Um, so you need a target object where control over that ref count field yields something useful. And it seemed to be difficult to do that with the objects in this cache, though he does point out it should be possible but painful, because for example, you could get corruption on a pointer field being the buff field in the sec file object, but you'd end up corrupting the upper 32 bits of the object, not the lower 32 bits, and that is much tougher to exploit because yeah, like not being able to control those lower 32 bits, you would have to do some serious heap manipulation to get that to work out. The strategy he ultimately went with here was a somewhat common one in this situation, and that's forcing a page reclaim so that the page that contains the UAF object gets reclaimed by a different cache. You could go with like the generic cache, but the cache you went with here was the page table cache, and that allows a much easier reallocation primitive. It does take some effort to do that also, because you need to force that page to get flushed by allocating a bunch of objects to occupy that page, get the target object allocated as the last object, trigger the UAF, then free all those other objects to eventually get that page release triggered to get it back to the page allocator. So there is some serious heap manipulation going on with that strategy too, but I think it's a little bit easier than trying to get something useful by controlling the upper 32 bits of a kernel pointer.
It's a
tough.
bit easier, but it also it leaves you in a much better position, because once it's freed, you can reclaim that with, pretty much anything that the kernel uses. Like, you have just so many more options for a stable exploit.
Yeah. So basically, once Jan had that ability to get a page reclaim going, they overlapped the PID object with a page table. Specifically, he was able to smash the least significant bits of a page table entry, which could be used to enable read-write flags on a page that's supposed to only be read, for example. So you could use that to gain write access to a set UID binaries text segment and use that to privilege escalate. So this is kind of another thing where you're using a kernel corruption primitive to attack from the user side a little bit, because you're kind of attacking the set UID binaries. And this is a very interesting attack scenario, because ultimately it never hijacks control of the instruction pointer in the kernel, nor does it require any kind of leak or anything to chain with due to corruption being an increment. And as such, Jan points out here that mitigations like CFI wouldn't have done anything in this case, because you're never touching the control flow. You're just using your corruption primitive to corrupt some page table entries that you can use in a second stage of the attack. He does point out some mitigations that could be useful in preventing bugs like this. I mean, the most notable one there just being mitigating the attack surface so that you can't hit pseudo terminals in the first place, because most components on the system do not need access to that. It's just kind of an unnecessary risk to expose that. But some of the other things suggested were like randomizing structure layouts to impact the reliability, and mitigating UAFs in general by using something similar to memory tagging to tag pointers on the type of object it's supposed to be. So there's a lot more nuance in there, and he goes into detail on a few different defenses there, which I'm kind of skipping through because it would be impossible to cover them all here. As per usual with Project Zero, it's a pretty dense blog post. It covers a lot.
Yeah, it's a really good post, though, to give a read up for some of the defenses. Talks basically about what they are and what they would or would not actually be able to do. You already somewhat called this out, but the fact that this doesn't corrupt or doesn't hijack control flow, and he calls this out in the post regarding control flow integrity, and basically CFI would have done nothing here. And in the last few months, I've been in a few discussions where it comes to like, oh, CFI is going to kill so many exploits, and I mean in the kernel, more data-oriented attacks has just been very natural, made a lot of sense, because the kernel holds on to a lot of very important data. but you don't really need code execution there. You just need to corrupt the data. Like even with code execution, you're usually still going to want to get a userland process privilege rather than trying to do everything as kernel code. So it's made sense there, but in general, like these sorts of data-oriented attacks, are generally becoming more prevalent, and as control flow integrity becomes more prevalent, will be, I guess, more of a default option. So I did just want to, I guess, call that out here, that this is one of those cases where CFI would have basically done very little, but data attacks are important to be learning about if you're not already abusing them.
Yeah, running code in the kernel is very overrated. I learned this lesson the hard way when we were trying to do some PS4 stuff and we were trying to write a kernel rootkit. And we just learned, like, we got to take this stuff to userland because this really sucks trying to do this in kernel. But yeah, I mean, like you said, the common strategy, even if you do get code execution in something like the Linux kernel, is literally just to jump to a function that changes your process privileges and then return. You're not doing anything crazy. It's like a one call chain. Um, and, like Amy said in chat, like data attacks are just, that's the way of the future. It's a lot more reliable. And it gets around mitigations like CFI.
Yeah,
And
which I mean,
revisiting CFI a bit, I agree. It's not really the mitigation to be worried about
it's
for the
going to
most part.
change things as we see it. Hardware enforced CFI is going to change aspects of exploitation. No doubt about that, and it is coming. Um, but at the same time, there are other options. I mean, even obviously we're talking about kernel right now, but there's this there was the suid exploit that we covered earlier in the year. In that one of the attack options was attacking some of the data that suid used. I believe it was the log file or like a. Yeah, I'm pretty sure you basically got control of the log file as data, and then had your output go. I think they targeted log rotate too. Actually, so we were just talking about with the other one. They targeted a log rotate config. So yeah, I mean, that's kind of more of a data-oriented thing in userland. A lot of more complex applications have some sensitive data that you might be able to abuse. Out of chat, there was what CFI, like CET. Yeah, CET is the form of CI. I guess Spectre already got on this. But yeah, CFI, control flow integrity, CET, Intel CET control, was it control flow enforcement technology, I believe is.
Yeah.
And on Windows, they've started implementing that, giving raw protection, so protecting the backwards. It would be called backward edge control flow integrity versus forward edge being all your forward jumps. I don't believe Windows has protection on those just yet, although that is where something like Clang CFI, GCC as CFI, those do the forward edge protection.
Yeah, I believe CET is planned to do both.
Oh,
I believe it does
CET
both
does
forward and
it. Windows
edge.
implementation does not. But CET supports it.
Yeah.
Like it's there. Windows just hasn't implemented it yet. At least that's my understanding. I haven't, double checked on that one, but I believe the case is Windows specifically and their implementation. But yeah, CET supports forward and backward edge.
Yeah. And when I was talking about mitigations and saying CFI is not the one to be worried about, I was just kind of jumping back to that discussion where you were saying people were worried about CFI being like an exploit killer. If you want to attach a mitigation to being an exploit killer, attach it to memory tagging, because that's coming and it's going to be way more impactful than CFI is going to be. Memory tagging is going to impact memory corruption across the board.
Yeah, I mean,
it's not
memory
going to kill
tagging-
it entirely. There are some problems with it, like when you get into the granularity, is like the primary one that you could attack, but it is generally going to kill a lot of bugs and a lot of bug classes.
Yeah, I mean, memory taking does actually provide a little bit of a CFI. So it's kind of like with PAC, how PAC pointer authentication over on iOS, it provides a degree of CFI, but it also kind of does some other things, make pointer overwrites in general hardware, and it's some sorts of out-of-bound access. Like it protects against more than just CFI, but then it's not quite the same strength as a shadow stack or something for backward edge. So I mean, memory tagging, yeah, like it's weird, I guess. I'll put it that way because it's not as strong in some ways, but it does more.
Yeah, it's going to be more like wide sweeping against different types of bugs and stuff.
Yeah.
Um, so yeah, I mean, Google is pushing for that. Um, Andre gave a talk recently at the Linux Security Summit, and there's already been support added in the Linux kernel for um, memory tagging. Now that is taking advantage of like ARM memory tagging. So in this case, like this blog post and this attack, I believe is targeting like x86 memory tagging. I haven't really seen much on the front for x86 for memory tagging in terms of hardware support. I don't know if that's coming. I don't know if Intel is actively working on that or AMD is actively working on that. I just haven't really seen much. It seems to be more like the mobile space, like ARM has really been tunneling in on the mitigations, and they've always kind of been like that. ARM has always been ahead of the curve, I guess, on mitigations. But I eventually it will come to x86, I have no doubt, because like I said, it's a strong mitigation. I would
I
be shocked
remember
if it
hearing
doesn't come to
something
x86 soon.
about, and yeah, it is a strong mitigation, so I do still kind of expect it, but I do remember seeing a discussion once, and I'd have to go check this, that there might have actually been, or part of the reason it has been seen is purely because of the spec and backwards compatibility, not basically something in there disallowed actually using those bits for other purposes, um, like memory tagging tends to do. So I don't know. It sounds like there was some reason that we haven't seen it, but I'm not familiar enough. I will also, since we were talking about the talk from Linux Security Summit, since that's already up on YouTube, I will also include that in our description below.
Yeah. And Sarsek asked, how does memory tagging work? So this is actually something that's covered in the talk very well. Basically, they use some bits out of the pointer to store a tag, and there's like a kind of like a shadow table that keeps track of different memory locations and what their tag is supposed to be. And the CPU will check when it does any memory accesses, it'll check that tag to make sure that it matches what it's supposed to match. And if it doesn't, then it aborts. So it's a fairly straightforward concept on how it works. Obviously, the fact that it's hardware implemented is very important because doing this in software would be absolutely horrible for performance. But yeah, the CPU is responsible for doing that. Um, there are some weaknesses in the way that it's implemented because, for practicality reasons, the granularity I think is like 16 bytes or something. So like if you have an overflow and you can control uh the other thing memory tagging enforces is the like memory contents. So because of the granularity, there are some weak spots in memory tagging, which will probably be tightened over time as the performance overhead gets lower and lower. But yeah, I mean the essence of memory tagging is the idea that pointers can have tags in them. And it's a very interesting technology for sure. And I would recommend giving this talk a listen. It
Yeah, it's a
was one of the
great
best
talk.
talks that I've listened to. Yeah, it was really good. So yeah, if you have some time, put that on for sure.
Yeah, and we also, so it wasn't exactly about this in the more practical case, but we did also talk about the Morpheus chip. Actually, we've talked about it a couple times. I'm having trouble finding which episodes
We
we've
talked
talked
about it a
about it in.
long time ago.
Well, we
So
talked about it earlier this year when they did the update and like it was tested. I think Bug Crowd had it up there and they had some DoD had like a challenge against it. And had no problems with it. It did memory taking. It did a bunch of other things too, but I'm pretty sure I went into explaining kind of how that works a little bit more in that talk, although I talked about the other, or in that episode. Unfortunately, I'll see if I can get the link in our show notes. I don't have it on me right now.
yeah. So jumping back to this topic a little bit, the vulnerability is relatively straightforward with it just being a broken lock leading to a race condition. In fact, one of the other things that Jan Horn points out here is something that would be nice to have is some kind of static analysis tooling or like compile time checks just to check that the locking kind of follows the paradigm that was outlined in the driver. Because if you had something that would check the like locking compared to the data structure accessed here, it would have been like fairly obvious if you had something that was looking for that. Um, Where I think this blog post is a lot more interesting is on the exploit dev side. I really liked that trick of smashing page table entries in order to change like memory page permissions. I think that's a really cool attack, and it's a very useful attack because, like I said, going with this route, you don't have to do any leaking or chaining with any other bug, which is very valuable. Not having to rely on an info leak is huge. And being able to bypass mitigations like CFI is also huge. So yeah, very impactful exploit. Fairly simple bug though, and that's
Yeah,
why
simple
most of the
bug.
blog post is dedicated to defenses and the exploitation angle.
Yeah, I mean, everything else that they went into on this one, I think, is what added a lot of value to the post. Not that having the exploit in there wouldn't have been valuable. And also, it was our 9th episode where we talked about the Morpheus chip.
What was that, like 3 years ago?
Um,
That was
good while ago. It's old enough that it's not even on our website.
there. You go. Nice.
Our site starts at episode 12.
But all right, so we'll move into our last topic of the episode here, which is a Chrome in the wild bug analysis. This was a vulnerability in the garbage collector, use after free, which, as the author points out, is one of the most complicated components of the browser. As such, this is going to be a pretty heavy topic, and I'm going to do my best here, but I am mostly operating off of what I could read from the blog post because even though I've done a bit of browser exploitation, the garbage collector is something that I've often just treated as a black box. It's not something that in most cases you need to know the intricate details of how it works, which is actually touched on in this post.
Yeah, I mean,
So
this was I preferred this post over the last Chrome bug that we covered, like last week's one, I think it was.
Yeah,
I thought it kind of explained things reasonably well. I mean, there are some issues. Part of that's just on me for not doing a lot of browser exploitation. That said, to give a really, really quick summary of it, basically just comes down to having an object freed when it shouldn't have been. Obviously, there's a ton more details to that, but
that's leaving a lot of nuance.
that is leaving a lot of nuance. But just so you know what we're trying to explain, as Spectre dives into it more, like that's the big picture, the really big picture of it. Is it loses track of some items and forgets to mark them and ends up freeing them instead of marking them appropriately. I'll let you go on, though. I just wanted to give that big picture thing for anybody coming into it.
Fair enough. So yeah, where this is dealing with such a complex component, they have a lot of background information covering like how the garbage collector works. And you kind of need to know a little bit about how it works at a high level to understand the bug. So for those not aware, browsers have garbage collection running to clean up any unused objects. Fairly standard in like managed languages like this. And the way that the garbage collector works is at various intervals or when under memory pressure, it'll run this mark and sweep strategy where it'll check all the objects that are currently live, check for any strong references to them, then mark them if any references are found. At the end of that marking phase, any unmarked objects will get cleaned up and freed. Now, obviously, there is more to the garbage collector than just the mark and sweep strategy. The blog post goes into some other things about what the garbage collector does, like some performance optimizations and concurrent marking, but those aren't really necessary for understanding the bug, though concurrent marking is relevant for stability of exploiting it, but I don't know how much we'll go into that. But yeah, you'll note earlier that I said that it checks for objects in the mark phase for strong references. And that kind of implies that there can be weak references, which there are. There is a data structure called a weak map where you can store an object in the map without preventing it from being garbage collected. I'm assuming this is like a performance thing. I'm not totally sure. I meant to look into that a bit more, but I forgot to. But anyway, in that case, there's special handling required when running a GC pass. And they call this relationship an ephemeron, and any key value pairs in this weak map are called ephemeron pairs. So they have to be careful to ensure that ephemeron pairs with values that are reachable, in quotes, from other objects aren't collected when a GC pass runs, or you can run into a use after free situation. So because of that, weak maps maintain a hash table object, which when the garbage collector reaches that object and a key in the pair wasn't already found to be reachable, it would be queued to be checked later at the end of the cycle. Because until you reach the end of the GC cycle, it's impossible to tell whether or not a value or a key could be reachable, because they haven't processed all of the objects yet. So it's kind of a weird situation. It's a really hard case to handle. So at the end of the cycle, it goes back through the discovered ephemeron pairs and tries to check for references.
And just
And
to interrupt really quickly,
yep,
I believe Amy or Itzian in chat said it's useful for making caches, so kind of calling out where the weak maps are useful. Having a cache, it's going to, anytime an object does get removed, it's going to automatically be removed from that weak map also. Yeah, kind of makes sense for that use purpose.
okay, cool. Thank you. So that makes sense. Yeah. So at the end of the cycle, it goes back through the discovered ephemeron pairs and it tries to check for references. It does this in 3 stages. So the first stage processes the current ephemerons list that were already discovered, and it pushes entries assumed to be unreachable into the next ephemerons list. The second stage tries to discover any new ones, any new ephemerons, and push those also into the next ephemerons work list. And here it might discover some new ephemerons with something like an embedded weak map and its entries. And then the third stage takes those newly discovered ephemerons and processes those. And it just continues to do that until no more objects are added. But some of the objects in the second stage where it can discover those new ephemerons, those might have strong references to what were previously assumed to be unreachable ephemerons, and those values never get marked. So they can be erroneously collected by the garbage collector despite there still being strong references to it. So the example the author gives is if you have 2 key value pairs where you have one which is a simple key value pair like just K1 and V1, and a second one where the value is the key of the first value pair, it's possible that that first pair is visited, K1 and V1 are unmarked because they don't see any references. And then when K1 is visited, K1 will get marked, but the value for K1 won't get marked. So you kind of have this desync where the key for the first pair is marked, but the value isn't, so it ends up getting collected. So the patch there was to make sure that if there were a non-zero number of objects processed when draining the work list, that they run another pass to ensure that the ephemeron semantics get applied. There were some other complications in exploiting this bug. For one thing, they had to add an additional few key value pairs to the weak map due to there being 2 rounds of ephemeron marking. And the other thing was concurrent marking gets performed prior to garbage collection. This one I can't really go into detail on because it goes pretty far out of scope of my understanding of the GC, and it's an optimization kind of thing, so it's bound to be really complicated. But to account for the concurrent marking, they had to get creative with nesting weak map objects to change how like the graph, the object graph, looked to the engine. Even then, the bug was still somewhat unreliable to trigger because you need your key value pairs in the desired order, which might not always be processed that way because of the nature of hash tables. You'll remember, like, the way these key value pairs is tracked is through a hash table. That hash won't be deterministic, so there's a bit of RNG there. It depends on what hash is calculated and in what order your key value pairs are put into that table. What this bug essentially provides, though, if you are able to exploit it as a primitive, is a very strong primitive. It basically allows you to do a targeted use after free of any object in JavaScript that you want, because you can just store an object reference in a weak map, trigger garbage collection, and then pluck that reference back out. From there, you can go the more known route of like UAFing the backing store of an array buffer and causing a type confusion there, or you can use a trick of abusing how large JS arrays work, where the backing store for large JavaScript arrays is allocated in this large object space heap, which is a separate heap from most other objects. And that's a special heap arena where you can get other objects allocated of different array types. So you can get an object array and an array of doubles allocated in the same space, use the UAF to cause an overlap, and once you have that type confusion, you can use your overlap with an array of doubles and an array of objects to get the game over primitives, being the ability to leak objects through the array of doubles, or the ability to create objects by writing into the array of doubles. And you can use that access to the object array to retrieve the reference to those fake objects. And from there, it's pretty easy to get a read-write primitive. if you want to know more about that strategy, I don't want to cover it too much here because it does require some knowledge of how arrays and stuff in JavaScript work. But the attacking JavaScript engines by Salo does a pretty good job of explaining it. Attacking JS engines, I believe, tunnels in on WebKit specifically, but Chrome is also very similar. Like browsers in this area, there's not a lot of divergence in how arrays and stuff work. So I'll link that in chat for anybody who's interested. We'll put the link in the video as well. But yeah, if you want more details on that, the Attacking JavaScript Engines paper is a really good resource for that. But yeah, I mean, overall, a really complex vulnerability and a very hard to spot one because it's deep into an area that not a lot of people are looking into because it's just way easier to treat it as a black box, even for security researchers doing browser research. So yeah, just a really hard to spot bug, very complicated exploit, not super stable because of the RNG aspect to it. But which makes it
I'd be a
interesting that
little
it was discovered in the
curious.
wild a little bit, but
I'd be a little bit curious on the discovery aspect of this one too. Just because, like you're saying, it's a hard to rock area. Also kind of hard to fuzz. I mean, there's probably some ways you get around fuzzing it, but it feels like one of those areas that would be a little bit difficult. I believe.
yeah, so Chrome
like,
did sorry, go ahead.
oh, I was just going to also call out the fact that Project Zero also did a RCA post on this bug.
Yeah, so I was just about to reference that actually.
Okay, yeah.
Because in the wild post from Project Zero, their RCAs, they do include a section on how they speculate that this vulnerability could have been found. And even they were kind of like, they suspected that it was manual review because it seemed harder to find this through fuzzing than it would be through manual review. But even they were kind of unsure because it's just such a deep and complicated bug. This is one of those bugs where you really need to understand the subsystem and how it works as a whole and how different parts interact with each other. It's not like a straight up like, there's an error path that frees this and then the function above that might use it or something. Like it's not a straightforward use after free. It's a very complicated design level issue.
Yeah, like especially if you were to imagine getting just the crash report on this, trying to triage it. I could just imagine how painful that would be.
Yeah, it would suck. So, yeah, I mean, props to like the researcher here for doing all of that legwork, because this, yeah, like you said, this would be very hard to backtrack off of. So, yeah, I do find it a little bit interesting that this was discovered in the wild, just because like where that RNG aspect is in it, with the hash table, it doesn't seem like something you can easily control from an attacker's perspective, which means the reliability and stability here seems like it would be somewhat low. So it's just kind of interesting to see that being used in the wild because, whenever you have a crash, that's obviously not a good thing if you're trying to use a 0-day, because if that crash gets back to Google like it did here, it can be, discovered. It's noisy. So yeah, a little bit interesting that such a complex and hard to hit vulnerability was found in the wild, but nonetheless, I mean, the vulnerability and the exploit here is really insane. And as such, like, I hope I did a somewhat okay job of explaining the vulnerability and the internals there. It is like, whenever we get these browser bugs that are deep in some complex component, like turbofan or the garbage collector in this case, it's really difficult to cover because it does require a lot of internal knowledge on the browser to fully appreciate. And it's just really hard to convey that, especially where I'm not a Chrome researcher. It's like a full-time thing. So I'm kind of going off of what's written here too. So
I've been appreciating getting a bit more knowledge in that area through these posts though, and through doing the podcast. Because we've had a few over the last couple weeks.
Yeah, ones that are a struggle to read through, but you learn a lot through doing so. Yeah, for sure. Amy said, I find it less surprising that a hard to hit bug was found. So yeah, like on the one hand, the fact that it's less reliable, it makes sense that it was discovered with the crash report. On the other, it seems interesting that someone would even bother trying to use it, I guess.
I
I
mean,
mean, I
if you're
guess when
looking
you're
for
talking
it,
about a browser, like any bug is useful. I guess you're not going to be super picky on the reliability as much as you might be with some other targets. But yeah, it just seems interesting to me that such a 0-day was even really deployed. But I mean,
yeah,
that's
I
pure
mean that.
speculation on my part. So
Yeah, I've never been involved with like that level of cyber operations to know how they make such a decision on what's worth deploying or not. So I'll leave it as obviously somebody did find the value in it.
yeah, and Sarsec suggested like maybe an underfunded state actor. I mean, yeah, there's probably a lot of reasons out there why you would go with like a an exploit like this where it might not be super reliable. But yeah, I mean, I can only do some shallow speculation on that because yeah, I can't jump into the mind of whoever deployed this vulnerability, and Google doesn't even seem to have information really on who deployed this, so you can't even go too deep on that either. So, but yeah, like jumping back on the technical details and stuff, very interesting. The post I think was a little bit tougher to read than it could have been. I think they did go into some detail on like the concurrent marking and stuff where they didn't really need to, at least not before covering the vulnerability itself. Maybe when getting into the exploitation section, that might have been more relevant, but yeah, I think it could have been written in a little bit more of an accessible manner, but I mean, I'm not going to fault the, author on this one very much because like I said, when you're trying to cover such a complex bug, there's a lot of it's hard. You got to make a lot of decisions on like how deep you want to go into a specific area and how much you want to assume the reader knows. Because if you try to include everything and make it accessible to anyone, even someone who hasn't looked at a browser, you're probably going to be looking at like a 20,000 word post. So, and that in its own right makes it kind of hard to read. So, yeah, I mean it's tough to strike that balance.
Yeah, I mean, I'm actually going to take it's the end makes one good suggestion here. They needed more GIFs, just to break up the monotony of just this black on white text. So more GIFs, more memes.
I mean, especially when you're talking about the internal data structures in the hash table, I think an image or a diagram would have been extremely useful there. So yeah, that would have helped a lot. But overall, still a good post. And if the vulnerability sounded interesting to you, I encourage you to check it out to get a more detailed understanding. That said, if you're not too familiar with the browser or like the garbage collector, it might be difficult to jump into. You might have to do a lot of background research to appreciate it. But yeah, so that's pretty much all of our topics that we have. We do have a shout out or two. We'll shout out FuzzCon Europe. That happened recently. We watched a few of the talks out of it. I think I watched two talks. I think you watched. You said it was like two or three.
Yeah, I've
Um,
watched a few more. I'll give a shout out specifically to the input languages for effective and focused fuzzing. I found that one pretty interesting. Just some ideas on it. It's basically about using like grammar based fuzzing. Um, and I will also shout out on the not necessarily less positive side, but I saw API level fuzzing, how to harden your REST endpoints, and I thought that could be useful more for like even mentioning on our Bounty podcast. Um, Ultimately, it ended up being more of like a QA level testing thing, so it wasn't that interesting that I spent my time on. But I mean, it wasn't a bad talk, just not quite what I was hoping for.
yeah, so the talk that I thought I'd shout out is the libAFL talk. Um, Mainly because I think it's good if you're new to fuzzing and you want to learn a little bit about fuzzing infrastructure and how different components can work together. They have some really good slides talking about um, like how you would separate a fuzzer into modules, like how you would build a modular fuzzer, and that I think is like a really cool concept. And trying to abstract fuzzing into like a generalized concept, like there were some useful slides there for sure. That said, if you're already somewhat versed in fuzzing and you're familiar with a fuzzer that already kind of uses that concept, you might not find it that interesting. because a lot of the other part of the talk is like how to actually use libafl specifically, which I mean that makes sense. That is ultimately what their talk is about. But if you're not looking into using libafl or interested in what it offers, then the second half of the talk might not be super interesting to you. But I think for beginners who want to learn stuff about fuzzing, that talk can be very useful. The first half of it. So yeah, I did want to give that a quick shout out. Yeah, there wasn't as many talks at FuzzCon Europe as I like initially thought there would be when I first started looking, but
It's a one day. All of these talks are like a half hour.
Yeah, somewhat smaller conference. There might be some talks there that of interest to you, so we just wanted to shout that out. But yeah, there was nothing there that was super interesting to the point where we wanted to dedicate like a long discussion to it. So yeah, just wanted to shout it out. I think that pretty much concludes all of the shoutouts that we have. Z, I don't think you have. If you have anything more to add,
Nope,
I'll let you shout out here. But all right, so we'll wrap it up. So thanks to everyone who tuned in. You can catch the VOD on Twitch or on YouTube at 8 p.m. Eastern on Wednesday. We also have previous podcasts up on Spotify, Apple Podcasts, and some more resources on Anchor. Feel free to join our Discord and follow us on Twitter. Links for those are down below. I'll also link the Discord and chat. We'll be back next Monday for our bounty episode at 3 p.m. Eastern, 12 p.m. Pacific, and next Tuesday at the same time as today, 7 p.m. Eastern, 4 p.m. Pacific for the binary episode. And we'll see you all then.